what is document control and what is it purpose is served. So one thing that's interesting, AS 9100 states that you have to have a documented procedure that controls how documents are controlled. So somehow you have to write a control document that tells you how to control documents, which is kind of fun on its own. But what does that mean? You need to be able to have an appropriate level of control for data. There's a couple of things that really make that necessary. First of all, document control means that before something is released, that the appropriate people have looked at it and said that it's correct. You want to make sure that people are looking at stuff that is right, that is correct, and that needs to be reviewed. You need to be able to have those reviews applied as the document changes over time. Just because it was right once doesn't mean that after it's changed and iterated that every one of those things is still right, unless you have an approval process that lets you make sure that each of those changes are good. You need to be able to identify the document and its changes to it. There's several different ways of doing that. We'll talk about how Duotech handles that. And we need to make sure that the appropriate versions of that file are available to the appropriate people where they need them. You don't want one person to have made a change to a file, but the person who's doing the assembly is still using the old one and still building it wrong. Right? So part of control of documents is making sure that the right version of the document is available to the people wherever they need it. We need to make sure that documents are usable. Right? Now, in the old days, that made sure that you didn't have copies of paper that were so degraded that you could no longer read them. But for today, that means that I need to make sure that the files are in formats that the computers can still read. I can't access maybe old versions. We've actually had some of those issues. We had circuit board designs that were done in Mentor graphics. Well, I can't open those anymore with modern tools, so I need to make sure that I have a process for either bringing those files up to date as software changes over time, or storing them in formats that are going to have longevity that I'll be able to access later on. You need to make sure that documents that we don't generate in-house are controlled to an appropriate level. I don't want, again, if I have a manual for a piece of equipment and the publisher for that manual updates the manual, I need to make sure that I get and I'm using the updated manual, not keep using the old one. And so I need to be able to control even documents that are outside and to not be using documents that are obsolete. So what I'm going to do is jump over to our actual document control system. From the menu, there is an option that we did not look at before that says document control. So this is the location for where the core of document control happens. Now, all still part of the IDMS. It's the same login information as what you have if you've been granted access to this part of it, but you do have to log in a second time if you want to make any changes to the system. But you can reference and access documentation without needing to sign into this thing. So the main thing is we need to be able to find existing documents. All documents, in order to be tracked, have to be identified first. You have to have some way of identifying those documents. Duotech uses a 7-digit numbering system for documentation that can have some optional prefixes. There are two different types of numbers that are used. The first are ATP, acceptance test procedure numbers, which are generated for external equipment. So if we have data equipment that we build, we get to fully control the numbering of that part, all the assemblies, the systems, the subcomponents of it, and the documentation that goes along with it all lives inside of our numbering system. But if a piece of equipment or a part or an item that an external vendor has produced is in for repair and I need to write documentation that relates to it, that number is not in my numbering system. So we use a prefix number system that is the 4-digit year followed by just a sequential number. So as an example, we can have 2017001001, 002, 003, 004, 005, whatever other documents get created, and new ATPs can be signed out, and the system will automatically generate the next sequential number for you. For internal generated documents, then the information that is tracked is a 7-digit number starting with a 35, and those numbers have been ongoing for a number of years. So we're in the 358s now somewhere, but I'll pull up a few of these. You can see the way that they're kind of structured. You have a 7-digit number. Anything that ends in a 00, a 00, is a top level or sub assembly. So a 00 drawing is something that is comprised of, a number of parts or sub assemblies within that thing, and related documentation for that particular thing is all stored together. You can also search within this by keywords within this, the title of the drawing itself. If I was to go to a particular item within that 00, there could be a number of other, those 99 other documents that are associated with that thing. There are also prefixes. You can prefix a number with a PL, that's a parts list. You can prefix a number with a CAM, a CAM file that's related to a particular part. I'm sure the mechanical guys will be quite familiar with that. Underneath of there are some general locations. 20s and 30s are components, 40s are cables, 50s and 60s are software, 80s, 90s are manuals and assembly instructions. The 07 is a test procedure. So if you see a document that ends in a 34, you can most likely assume that it's a machine component or some other, whether it may be a gasket or something, but some other component that we made for that top level assembly. Assemblies can be small. They could be a couple pieces that are mechanically put together. It could be a circuit card, or it could be an assembly of assemblies. It could be a thing that has, 3 different circuit cards plus some electrical pieces that are all put together with some mechanicals, that then all of that is incorporated. That's its own assembly, and then that's incorporated into another higher level assembly, and it can be nested as deep as it needs to be for the level of complexity of the end product. Sometimes there are 00s that are used to just associate some documents together, and there are a couple that have been used just as placeholders for unaffiliated miscellaneous mechanical drawings and things of that nature as well. To start with, if you need a document, a drawing for something, your supervisor will get one for you until you've received more training and become more familiar with the document numbering system. But it's important to know that when you're working on something, to get that document number as soon as it's necessary, because the longer that you try to be working on something without breaking out the parts and the document numbers, the harder it's going to be to track the changes and to keep track of things in the way they need to be tracked. So the way that you would be looking at documents, anything, when we say document control, a document can be a lot of things. A document can be a mechanical drawing, okay, like we're used to seeing on paper. A document could be a schematic. A document could be a manual, a work instruction, literally a written textual document. But it's also anything that is controlled that can change over time. So it could be a piece of software. It could be a CAM program for a CNC machine. It could be the Gerber files for a circuit board. It could be, a test procedure that requires some software to be run, right? And so a lot of different things can come under that aspect of a controlled document. So as you're working through, make sure that you're aware of when do I need to identify this thing. If I have something that I want to make sure is retained, that is going to have changes over time, and it's related to some particular design effort that's going on, it probably needs to have a document identifier. If you're in doubt, ask your supervisor and probably go ahead and get one, because numbers are free and I have an infinite number of them. So go ahead and sign one out if need be. This does another aspect that this controls is the revisions and changes to the documents that are made. As we go into more detail, which I'm not going to go into here, but you can see that this particular drawing is listed as who needs to approve the changes. Does purchasing need to do it? Does the customer need to do it? Typically, at least one person is going to be required to approve any drawing. A document also has a source, and that source is stored in version control. We'll be looking at that in a little bit. But the source of the document and then the release of the document are separate things. The source can change, but only when it has been output and approved does that thing become a release. Once that thing is released, you can add change requests to that. I need to make a fix, I need to make an adjustment, I need to add a new feature, whatever that is. Those change requests can then be incorporated, the new output file made, the new release proposed, the approval gone through, and that process is there. The document then is versioned, okay, has a revision associated with it. That is how you know that the one document is different from another. Make sure that you never release two documents with the same identifier and revision level. So the unique identification of a particular document is its identifier, its document number, and its revision level. This case, there is a switch plate. It's identified with its number 3570122, and in this case it's a revision dash. It has not been changed, but if it was to be changed, it would be 3570122 revision A, then revision B, C, D, etc. Now, we have a hybrid version system for documents. You can use letters, you can use numbers, or you can use a combination of both. There's a couple reasons for that. Items like mechanical drawings, mechanical parts, typically revision letters are have historically been more common. They have a little bit of little ways that they're nicer. So you can have part, then you can have circuit card revision A, revision V, revision C, on up. And if you get a lot, then you could have revision AA, AB, that sort of a thing. Software, firmware, those sorts of things often are a little bit more prone to have small incremental changes that may not have impact on the actual operation of the thing. If you change a part one revision to the next, typically something has changed. If it's a circuit board, a component has changed, a trace has moved, some feature has been added to a mechanical component. If you have software, I could change the way something is done that doesn't actually change how the code really functions, what function that software provides. So version numbering is historically a way of keeping track. We use 3-digit numbers, minor changes, major changes, and interface changes, and incompatible changes to distinguish those. But then sometimes you can have kind of both. If you have a machined component that has an associated CAM file, that component has a revision level as that component changes. but you could create multiple CAM files that produce the same part. I could do one on different machines. I could rewrite it to make it faster, to use different tools, right? So but that CAM file still is producing a part to the particular revision. So you have to be able to version the CAM file independently of versioning the part, but at the same time you need the CAM to be associated to a particular revision. So if I have a part at revision, so if this is 3570122 and it was at revision A, and I had a CAM file, it would be at revision A, but then if I modified the CAM file to change it, but it still is creating a revision A part, then that would be CAM whatever A1, right, A2, so you could increment a number with that. On the flip side, if you have a piece of software that's identified by version numbers, I could have a document that's associated with the version. I could, let's say it's a manual, and it goes with version 2.0 of the software, but then I fix a typo in the manual. Well, that's not version 2.1. The software is still version 2.0. It's now 2.0 revision A. So you can use a combination of numbers and letters to identify the revision of a document.